Welcome back, everyone. In this lecture, what we're going to do is we're going to cover the basics of kinematics. So we're starting physics. Let me tell you something, physics is really hard. But if we work hard together, we'll get through it. Okay? So let's begin. Suppose I say, imagine you travel at 50 miles an hour for 10 hours. How far did you go? 50 miles an hour for 10 hours. How far? Let's write it out. Let's do this. 50, watch what I'm doing, miles per hour times 10 hours. Okay? What we have, hours over hours, the units will cancel. 10 times 50, okay, this is baby stuff, right? 500 miles. 50 miles per hour for 10 hours, we travel 500 miles. Fantastic. What did we do? Well, 500 miles is a distance. 50 miles per hour is a speed. Later we'll learn the difference between speed and velocity. And this is a time. So what we've written is our first physics equation, right? Distance is speed times time. I could write distance as d. Don't mix it up with density. Remember we wrote density before, okay? Speed we'll write as v and time as t. Once again, it's in a very simple form. D equals v times t. Using the laws of algebra, we could also solve this for v. V is distance over time. Look at that. Meters per second. Okay? Now, I'm going to write this as a change in distance. Change in, I put that in quotes, divided by really a change in time. Now, many of you already know this, that mathematically we write change in with the Greek symbol delta. So this is a delta. It's a Greek letter, and it really means change in. Okay? So if I did something silly, like wrote delta chair, the hell does that mean? Well, delta chair just means change in chair. Okay? Silly. Okay? So if I represent x as distance, then what does delta x means? Well, delta x just means change in distance. Also known as displacement. Okay? You tell me, what is delta t? Right? Remember, t was time, so this is change in time. Right? So now we can rewrite our speed in a really fancy, cool looking way, right? So we can write v, which is our speed, is delta x over delta t. Doesn't that look great? Just says the change in distance divided by the change in time. Okay? So before, we said the change in distance was 500 miles. The time, we said, was 10 hours. And what we end up with was 50 miles per hour. Well, that's what we said our speed was. Okay? Let's keep going with this idea of change. So, if I drive along at 50 miles an hour, you tell me, you've driven before, do you really drive at a constant speed forever and ever? Of course not. If you want to pass someone, you step on the accelerator. There's the word accelerate. We're going to accelerate. If we want to slow down, we step on the brakes. We decelerate. Deceleration is a negative acceleration. But really what we're doing, and again, we'll learn the difference between speed and and velocity later, but by accelerating or decelerating, we're changing our speed with time. So I'm going to write this. Acceleration. I'm going to use that delta, so get used to it. Delta V over delta T. So let's read this together. It's a change in speed. Later we'll use velocity, but for now I'm using speed. The change in speed divided by the change in time. Now, remember what V was. V was delta X over delta T. Delta, change in. What are the units of delta? There's no units. Change in is a word. There's no units. So let's look at X. What does X represent? X represents displacement or distance. Now in the United States or Brooklyn or even sometimes Staten Island, we measure displacement in things like inches, miles, feet, right? But in the metric system, what we're going to use for displacement is going to be meters. So if I look at the units of speed, it's going to be meters. That's the X. Remember, delta has no units. Divided by delta, no units. T, we're going to use seconds. So the speed is going to have units of meters per second. We write that as m over s. M is not mass. It's meters per second. Now we're writing acceleration is delta V over delta T. Change in speed over a change in time. Delta, what's the units? No units. It's a word, change in. So let's write the units of V. What's the units of speed? Well, we just said it. It's meters per second. Now, we have to divide by the units of delta T. Remember, change in time. Delta, no units. T, seconds. Seconds, okay. When you divide meters per second over seconds, I'm going to write m over s divided by s. The units, of acceleration are meters. I'm going to write the word out. Meters per second. Look at this. Seconds times seconds is seconds squared. All right? Now, what the heck does that mean? What is seconds? What does that mean? We read it in the book, we write it, we do stuff, but what does it really mean? So, if I may, I will try to explain it. Okay? So let's see if we can understand why it's meters per second squared. Okay. Now let's get back in our car. If we accelerate, the rate of acceleration, how fast we accelerate, depends on how hard we step on the accelerator. The greater we see and the greater force we put on the accelerator, the faster we go, the greater our change in speed. The greater we step on the brakes, the greater we slow down. It could be anything you want. Okay? It could be 5 meters per second squared, 3 meters per second squared, 6 meters, anything you want. But let's talk about things going up and down. Okay? If I take this eraser and I let go, well, right now, in this room, in this classroom, when I hold this eraser in this room, its speed is 0. If I let go, its speed changes. So what happens when I let go? Too smart, right? If I let go, it falls to Earth. Later on, maybe I'll tell you that the Earth also comes up to meet it, but that's something left for another day. This falls, speed is 0. Caught it. Its speed is 0. Its speed changes, it accelerates. Why did it fall? Well, everyone knows. The answer is gravity. But not everyone knows, if I ask the question, what is gravity? Now, you say, of course I know what gravity is. I've been dealing with gravity since I was a baby. I know what gravity is. What is gravity? Well, let's see. It's the Earth's pull on it's the attraction between two objects. Nah, that's love. Forget the attraction between two. It's the Earth's. How does the Earth act on this? So let me say, look. Suppose I put this eraser on the table and I push it. You see, I'm physically touching it, pushing it. Now let's get back to this eraser. How is the Earth saying, come to me, fall, come to me? Watch. I'm going to take an envelope and I'm going to block this force of gravity. Okay, there's nothing there, no strings, nothing. Watch, ready? It still falls. How? How does it fall? How does the Earth talk to this eraser? Okay? How does the sun tell the Earth, follow in an elliptical path around me? How? There's no string. You know, if you take a ball and put it at the end of a string and swing it around, why does the ball swing around? Because the string has a tension and it keeps it moving in a circle. But how does the Earth and the sun communicate? There's nothing there. So the question of what is gravity is such a deep question. Later we'll talk about Isaac Newton and his law of gravity. And he has this incredible law, seems to be true. But even Newton never understood what gravity was. He never understood what gravity was. It was up to Einstein to explain gravity. Once again, maybe we'll cover that in a later lecture. I'll tell you what gravity is. So forget it for now. This object falls and hits the ground. So we know it's accelerating. On Earth, there's an acceleration due to the gravitational force of the Earth, and I'm going to tell you what the acceleration is. The acceleration due to gravity on Earth, okay, is given by this. We give the symbol a special, we give the acceleration a special symbol, g. So when I write g is equal to 9.8 meters per second squared. How do we read this? Well, some teachers do this also, and most students do it. Say gravity is equal to 9.8 meters per second. No, gravity is not equal to 9.8 meters per second. The gravitational acceleration on the Earth, so it's the acceleration due to gravity, is 9.8 meters per second squared. Okay? Now, for what we're doing in this course, not in lab, but for the course and for the exams, here's what we're going to do. We're going to take G to be approximately, those are those wiggle lines, 10 meters per second squared. Now, I want to play with this number, okay? We're going to play for a while. And everything we do, because we can't do the real world, too complicated, everything we're going to do from now on is we're going to ignore gravity. Ignore air resistance. Okay, so we're going to make believe there's no air resistance. So let me tell you about G. It's the acceleration due to gravity. Again, 10 meters per second squared. Let's talk about what the second squared means. Okay, so listen to my words, see if you follow. If I take an object and I let go, ignoring air resistance, if I let go, what this says is that every second, the speed is increasing by 10 meters per second. What does that mean? It means if I drop an object, no air resistance, in 3 seconds, what's the speed? Well, the speed increases by 10 meters per second every second. That means after 3 seconds, the speed is, yes, 30 meters per second. After 7 seconds, what is the speed? 70 meters per second. After 11 seconds, what's the speed? 110 meters per second. Every second, the speed is increasing by 10 meters per second. So let's think for a second. Rain clouds. Where rain clouds probably 10, 15,000 feet up in the air. How come when it rains or hails or something like that, we don't go outside and the raindrops falling for many, 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 many seconds. How come they're not moving at like 1,000 meters per second? And we go outside and say, it's raining, help me, and we don't die. Well, the answer is air resistance. The air slows it down. This is the same reason when you drive in your car and you play airplane, you stick your hand out the window, you put your hand there and the wind blows it back. That's air resistance. Okay? We are ignoring air resistance. So when I say you drop an object for 4 seconds, the speed is just 40 meters per second. Is it really 40 meters per second? No. It's less because of air resistance. Okay? Now, here's a hypothetical. Ready? Suppose I'm standing on top of a building. On top of a building. Okay? Okay? There I am. Well, you can tell by the nose, that's me. Okay? And suppose I have a water balloon. And suppose I throw it down at a speed of 30 meters per second. And I want to hit my friend Vito, because he's a jerk anyway, so I'm going to hit him. I throw it at 30 meters per second. How fast is that water balloon moving 4 seconds later? Well, if I gave this problem on an exam, my first choice A, would be 120 meters per second. Why? Because it's going at 30 meters per second, and you would multiply by 4, right? But that's not what you do. Remember what the acceleration due to gravity means. It means every second, the speed is increasing by 10 meters per second. So 4 seconds later, if I dropped the water balloon, then you understand the initial speed is 0. 4 seconds later, the speed would be 40 meters per second, because every second, the speed is increasing by 10 meters per second. But I didn't drop it. I threw it at 30 meters per second. So 1 second later, how fast is it going? It's going 10 meters per second faster. So in 1 second, it's going 40 meters per second. 2 seconds, 50 meters per second. 3 seconds, 60 meters per second. And in 4 seconds, that water balloon is moving at 70 meters per second, because every second, the speed is increasing by 10 meters per second. Okay? So if you start at 0, 4 seconds later, it's 40 meters per second. If it starts at 30 meters per second, 4 seconds later, it's 70 meters per second. Okay? Now, let's play another game. What happens if I throw a ball straight up in the air? And let's say I throw this at 80 meters per second. So this is our initial speed. I can call that V0 or V sub I, the initial speed. Wish I could throw it that fast, right? Suppose I throw a ball up at 80 meters per second. Well, how fast is the ball moving in 3 seconds? Okay. Well, what happens in real world? Don't think physics, don't think about schoolwork. Just think what happens. Well, you know, when you throw something up, what's it doing? It's slowing down. Eventually, it stops. What is the rate of slowing down? Well, the speed is upward, but something's slowing it down. What is slowing it down? Gravity. At what rate is gravity acting? Well, again, the acceleration due to gravity was 10 meters per second squared in our approximation. So if I throw an object at 80 meters per second, in 3 seconds, well, in 1 second, it's moving at 70 because it slowed down by 10 meters per second. In 2 seconds, it's moving at 60 meters per second. So in 3 seconds, the object is moving at 50 meters per second. How fast is it moving in 6 seconds? Well, in 6 seconds, it slowed down by 60 meters per second. So if you started at 80, in 6 seconds, it's only moving at 20 meters per second. And how long does it get to the top? How long does it take? Well, in 8 seconds, what's the speed? It's 0. So at the top, the speed is 0. It took 8 seconds to reach the top. And at the top, this is the speed. At the top, what's the acceleration? Again, choice A on an exam would be 0, but it's not 0. The acceleration is always g. Acceleration is always g. Gravity does not stop acting on it just because it's at the top of the path. So, how long does it take to get to the top? 8 seconds. Can you guess how long this object is in the air? Well, look. If it takes 8 seconds to go up, how fast is it moving in 9 seconds? Well, 8 seconds, it's 0. So in 9 seconds, it's 10. In 10 seconds, it's 20. In 11 seconds, it's 30. So every second now, as it's going down, the speed increases by 10 meters per second every second. Okay? So at the bottom, the speed would be, this is 80 going up. Right at the instant it hits the ground, it would be 80 meters per second going down. How long is it in the air? Well, it's 8 seconds to get up and 8 seconds to go down. So this object is in the air for 16 seconds. Okay? What's the speed after 12 seconds? Well, again, in 8 seconds, what's the speed? Well, 0. Right? It's slowing down by 10 meters per second every second. So in 8 seconds, the speed is 0. In 9 seconds, it's 10. In 10 seconds, it's 20, etc. So in 12 seconds, after 12 seconds, V equals what? 12 meters per second going down. Okay? Let's do another example. Same problem. Now I'm throwing something up at 90 meters per second. What's the speed after 5 seconds? The speed after 5. Well, every second, the speed is decreasing by 10 meters per second. So in 5 seconds, what's the speed? 40 meters per second. How long to get to the top? Right? Every second, it's decreasing by 10 meters per second. And at the top, we know V equals 0, so it takes 9 seconds. How long is it in the air? Well, 9 seconds up plus 9 seconds down. It's in the air for 18 seconds. What's the speed after 11 seconds? 9 seconds, it's 0. 10 seconds, it's 10. 11 seconds, it's 20, going down. In 16 seconds, well, in 9 seconds, it's 0. 16 seconds, it would be 70 meters per second. Okay? That's not too bad. Not too bad. Now, I think that's enough for now. And in the next lecture, we'll extend this idea of acceleration to dropping and moving objects. Okay? And we'll see what we get.